March 1944, Thuringian Forest, Germany. Hauptmann Friedrich Hartmann pulled his Messerschmitt Bf 109 G6 into a climbing turn, the Daimler-Benz DB605 engine screaming at emergency power. Below him, the American bomber stream stretched across the German sky. B-17 fortresses in their combat boxes. Perhaps 200 aircraft, their contrails riding the day's destruction at 25,000 feet. He had been flying for the Luftwaffe since Poland. 5 years. In that time, he had watched his service transform from the victorious force that swept across Europe into something that bled pilots faster than the training schools could replace them. The radio crackled. Achtung, Indianer! The warning every German pilot had learned to dread. American fighter escorts. Hartmann rolled inverted and looked. The escorts were there, circling above the bombers at 30,000 feet. But they were different today. Not the stubby thunderbolts that turned back at the border. These fighters were slender, purposeful, with a distinctive belly scoop. And they weren't leaving. For 3 years, Reich Air Defense had operated on simple mathematics. American fighters had range limitations. There was a gap, a blessed, bloody gap, where German interceptors could work without interference. You climbed, you attacked, you survived, or you didn't. That gap was closing. Hartmann watched one of the new fighters roll lazily, maintaining station miles above the bomber stream with what appeared to be unlimited endurance. The silhouette was unfamiliar. Elegant lines, bubble canopy, that unusual ventral radiator. His tactical frequency erupted with voices. Someone from Toika Gruppe was engaging. Hartmann heard cannon fire, then a young voice screaming coordinates that made no sense. Then silence. He armed his weapons, 2 13mm MG-131 machine guns through the propeller, 1 20mm MG-151 firing through the spinner, 2 20mm underwing gondolas that added killing power but made the Bf 109 heavy and sluggish. The G6 was a brute, optimized for bomber destruction, unforgiving in a turning fight. Hartmann selected a combat box and dove. At 25,000 feet, the mathematics were brutal. The DB605 engine displaced 35.7 liters and produced 1,475 horsepower with methanol water injection, but it was gasping in air containing 40% of sea-level oxygen. The supercharger screamed, compressing thin air with desperate mechanical violence. The bomber stream flew at 180 miles per hour. To intercept, Hartmann needed to dive, building speed to 350, make his pass, then climb away before the escorts reacted. The climb was everything. Stay low for even seconds and the escorts would fall on you. The problem was energy. Kinetic and potential, the currencies of aerial combat. The Bf 109 could attack, but climbing back consumed fuel catastrophically. You might get 2 passes, perhaps 3, before your tanks ran dry. Hartmann armed his drop tank release, then reconsidered. He would need every liter today. At 800 meters, the sky filled with black puffs, defensive fire from the B-17's guns. These American gunners were veterans now, and they led their targets. 600 meters. The bomber filled his gun sight. 400 meters. He fired. The 20mm cannons hammered. Hartmann saw strikes on the B-17's wing route, the sweet spot where structure met fuel. For 2 seconds he held the trigger, watching aluminum skin peel away. Then he broke hard left, pulling 6 gravities, the world graying. Behind him, the B-17 continued flying. Its formation didn't waver. Hartmann swore. He had hit cleanly. But these American bombers absorbed punishment that would obliterate any German aircraft. He began his climb, nursing the throttle. The cylinder head temperature gauge crept toward the red line. That's when the new fighter appeared. It materialized in his mirror with mathematical inevitability. Hartmann's survival instinct registered simultaneous impressions. Slender fuselage, inline engine, bubble canopy, checkerboard nose markings, Fast. Very fast. Not turning, just closing. Pure energy tactics. Hartman broke right instinctively, but the numbers weren't favorable. His airspeed, 280 miles per hour. The American, at least 400. You didn't outturn an enemy with that energy advantage. You didn't outclimb him. You didn't outrun him. You made him overshoot. Hartman snap-rolled inverted and pulled through, a brutal split S trading all his altitude for speed. The acceleration crushed him into his seat. The airframe groaned. Negative G-forces lifted him against his harness, blood pooling in his head. The American followed. Hartman watched in his mirrors, judging closure rate. The pilot was good, patient, letting geometry do the work, maintaining position above and behind. At 5,000 feet, Hartman reversed into a maximum rate turn. The stall warning buffeted his stick. He ignored it. The American swept past, perhaps 300 meters away. The aircraft was beautiful. Clean, purposeful lines. A bubble canopy offering unobstructed vision. Wings that looked thin and sharp, designed in a wind tunnel rather than hammered out under bombing raids. The belly scoop was fascinating. A ventral radiator aerodynamically faired to minimize drag. Then the American turned. Hartman watched as the aircraft carved through air at a radius that should have been impossible for its speed. No skid, no slip. Just a pure turn bringing the nose around with terrifying precision. He had 3 seconds. Hartman firewalled the throttle, engaged MW-50 emergency power, and pointed the Bf-109's nose at the ground. Engine temperature gauges redlined immediately. He had 90 seconds at this power before the engine cooked itself. The dive took him through 8,000 feet. 6. 4. The airspeed indicator swept past redline. The airframe shook. This was Coffin Corner, where metal fatigue met pilot desperation. At 1,000 feet, Hartman pulled out, G-forces crushing him, vision tunneling. The altimeter unwound. 700 feet. 600. 500. Trees became individual and distinct. The American fighter was gone. Hartman circled once, scanning. The bomber stream continued east, untouched. The new fighters circled above like guardians. He turned west toward Oschersleben, nursing his overheated engine. Something fundamental had changed. The Americans had brought a fighter that could escort bombers to any target and back. A fighter with range, altitude performance, and speed that made the Bf-109 obsolete. They were calling it the Mustang. That evening, Hartman filed his combat report. The intelligence officer, Oberlieutenant Steiner, listened with polite skepticism. Checkerboard markings? Yes. And this aircraft outturned your Bf-109? No. It turned inside my radius while maintaining energy. That's different. How? A pilot can outturn me by bleeding speed aggressively, but he pays. He ends up slow and vulnerable. This aircraft turned hard without losing speed. That suggests lower wing loading or more efficient design. Probably both. Steiner looked up. You're making engineering assessments? Someone should. We receive dozens of reports daily about new American aircraft. Most are Thunderbolts misidentified. This wasn't a Thunderbolt. I'll include your observations in the daily summary. Hartman stood. You could describe what you saw, but until Berlin decided it mattered, observations evaporated into the machinery of reports and summaries. Outside, mechanics worked on his Bf-109 under portable lamps, replacing overheated spark plugs. The aircraft looked tired, oil-stained, patched, combat-worn. His wingman Kepler approached, hands shaking. Herr Hauptmann, I lost you during the engagement. I should have stayed. You saw the escorts and ran. That was correct. But you're alive. You'll fly tomorrow. That's all that matters. The boy walked away unconvinced. Hartman lit a ration cigarette and watched the mechanics work. Old men and boys mostly. The experienced personnel had been dispersed to critical industries. The Reich was running out of everything. Fuel, ammunition, pilots, time. And now the Americans had a fighter that could escort bombers deep into Germany. The mathematics of attrition had shifted decisively. Tomorrow there would be another mission, another bomber stream, another generation of escorts. But something had changed in the Air War's fundamental equation. Part 2. The Prize. April 15, 1944, near Kassel. The P-51B Mustang, serial 43-6819, crossed into German airspace at 28,000 feet with 75 gallons remaining. First Lieutenant Robert Pierce, 354th Fighter Group, had been flying escort for 4 hours and 17 minutes. This was the glamorous life of a fighter pilot. Pierce scanned methodically. 6 o'clock, 3, 12, 9, up, down, check instruments, check fuel, check temperatures, scan again, never stop. The bomber stream stretched ahead, already turning home. The target, a synthetic oil plant near Magdeburg, had been hit hard. His radio crackled. "Cobblestone leader, this is 4. I'm showing oil pressure drop." 4, what's your reading? "Dropping through 40 pounds, temperature climbing." Serious. The Packard V1650 Merlin engine was magnificent, but demanded precise parameters. Oil pressure was life. "Can you make the channel?" A pause. Pierce imagined the calculation. Fuel state, distance, engine condition, altitude available. "Negative, lead. I'm putting her down." "Understood. I'll stay with you." Pierce dropped from formation and tucked beside Cobblestone 4, Lieutenant Anderson, whose Mustang trailed white smoke. Oil vapor burning on exhausts. They descended together. At 15,000 feet, Anderson's oil pressure zeroed. The Merlin seized with a mechanical scream audible over radio. "Engine's gone. I've got the field." Below, through clouds, lay German farmland. Anderson picked his spot, a large plowed field, no obstacles. The mathematics of forced landings were brutal. One chance, no go-around. Pierce orbited, watching Anderson glide down, gear up, flaps down. The Mustang touched in a spray of dirt, plowing 300 yards before spinning and stopping. Canopy opened. Anderson climbed out, waved, "I'm okay," and started running. Then Pierce saw the trucks. 2 Wehrmacht vehicles bouncing across the field. They'd seen the landing. Pierce descended to 500 feet, considering strafing but discarding it. Geneva Convention rules about rescue personnel. Besides, Anderson was running. He climbed back to altitude, alone, the Merlin purring smoothly. His job now? Get home and report the loss. Major Wilhelm Hoffmann received the call at Rechlin Airfield at 1830 hours. "Herr Major, we have captured an American fighter, undamaged, near Kassel." Hoffmann set down his coffee. "Type?" "Unknown. Local Feld Gendarmerie report a slender single-engine aircraft with American markings. Forced landing. Pilot attempted destruction with thermite, but our men arrived first." "Condition?" "Intact, being guarded." Hoffmann felt professional anticipation. Captured enemy aircraft were intelligence assets, especially when Americans seemed to introduce new types constantly. "I'll leave immediately." Within 30 minutes, he was airborne in a Fieseler Storch, flying east with a navigator and 2 guards. The Storch droned at 90 miles per hour toward Kassel. Hoffmann had tested Bf-109s, FW-190s, and captured Spitfires, Yaks, and Thunderbolts. Each taught him about enemy engineering philosophy, manufacturing capability, tactical thinking. Lately, intelligence mentioned a new American fighter, a Mustang, appearing in increasing numbers. The reports were alarming. Extended range, high-altitude performance exceeding the Bf-109, escort capability to any Reich target. If this was a Mustang, Hoffmann wanted to see it. The field was guarded by Wehrmacht soldiers when Hoffmann landed just after 2100. Portable floodlights powered by generator illuminated the captured fighter, a gleaming silver aircraft sitting incongruously in muddy Germany, like something from a different, cleaner war. Hoffman approached slowly, professionally. The aircraft was smaller than expected. Fuselage perhaps 30 feet, slender and purposeful. Cockpit positioned aft for optimal center of gravity. The bubble canopy offered panoramic visibility, far better than framed German canopies. The wings fascinated him. Thin, 11 or 12% thickness ratio, and perfectly smooth. No protruding rivets, no panel gaps. The leading edge had a subtle curve suggesting laminar flow aerodynamics, a concept Hoffman knew from journals but had never seen successfully implemented in production. He circled slowly, noting everything. Landing gear narrow-tracked, folding inward with clean doors suggesting drag reduction obsession. Tailwheel fully retractable. 4-blade propeller, probably Hamilton standard, designed for high-altitude efficiency. But the radiator housing drew his attention most. Mounted under the fuselage aft of the wing, a streamlined scoop containing what appeared to be combined coolant and oil radiators. Hoffman knelt and studied the intake. The duct expanded internally, slowing airflow to pick up heat, then expelled it through an exit nozzle shaped for thrust recovery. Elegant engineering. The Spitfire used wing radiators that created drag. The Bf-109 used crude underwing radiators. This American design turned cooling into something approaching thrust production. Hoffman stood and circled to the nose. The cowling was tight and well-fared, with a carburetor scoop feeding the supercharger. Small exhaust stacks positioned to create thrust through jet effect. Every detail suggested obsessive focus on drag reduction and efficiency. He climbed onto the wing and looked into the cockpit. The panel was American. Large, clear gauges positioned logically, illuminated gun sight, radio panel resembling commercial airliner equipment, simple stick grip with trigger and camera button, throttle quadrant with mixture, propeller pitch, supercharger controls, and switches. So many switches. Hoffman had flown captured P-47 Thunderbolts, massive, powerful, but crude, like they'd been designed by truck builders. This was different. This felt like engineers asked to design the perfect high-altitude escort fighter, given unlimited resources, and actually built what they designed. Herr Major? A Wehrmacht guard stood at attention. The pilot. Standard interrogation protocols. Treat him correctly. He's a combatant, not a criminal. The soldier nodded. Hoffman returned to the Mustang, running his hand along the wing's leading edge. Perfect smoothness. American manufacturing, American resources, American engineering philosophy. Everything spoke of a nation that could afford to optimize every detail, with time and materials and skilled workers to build fighters with thousandth-inch tolerances. Germany built fighters with forced labor in dispersed factories avoiding bombing, using substitute materials because aluminum was scarce. Hoffman pushed the thought away. His job was technical evaluation, not strategic assessment. Get recovery equipment ready. Tow this to the nearest road and truck it to Rechlin. I want it flying by month's end. The crew moved in, professional despite the late hour. Hoffman stood back, still studying the Mustang in harsh floodlight. This was the enemy now, not pilots or tactics. This, an aircraft designed by engineers with time and resources, built by factories running multiple shifts, fueled by an industry supplying military and civilian needs simultaneously. Hoffman lit a cigarette and watched the recovery crew work. He wondered what test flights would reveal. He suspected he knew. Part 3. Understanding Through Numbers. April 18, 1944. Rechlin-Lards Airfield. The Mustang arrived on a flatbed truck, canvas-covered, guard-escorted. 3 days transport, roads damaged, fuel rationed, moving anything valuable through 1944 Germany required navigating bureaucratic mazes. Hoffman watched the crew remove tarps in cold morning light. The aircraft looked cleaner here, in Rechlin's professional environment, than in that muddy field. Waiting with him, Oberst Kurt Schneider, test center commander, career officer who'd lost his left eye over France in 1940. Diplal and Junior Ernst Weber, senior aerodynamics engineer from Messerschmitt AG. Hauptmann Franz Keller, test pilot with 2,000 hours on Bf-109s and combat experience in Russia, France, and Reich defense. "Gentlemen," Hoffman said quietly, "shall we begin?" They moved the Mustang into Hangar 7. The recovery crew had performed preliminary inspection. Engine seized, oil drained during landing, but otherwise intact. Fuel tanks empty, ammunition full, 6 50 caliber Brownings, 3 per wing, approximately 1,800 rounds total. Weber approached the wing first, kneeling at the leading edge. "Laminar flow," he said quietly. "Look at the smoothness, the profile." Hoffman joined him. The wing's cross-section was elegant, thin teardrop gradually thickening aft. Maximum thickness at approximately 40% chord, much farther aft than German fighters. "The Americans have solved it," Weber continued. "Maintaining laminar flow over the surface. We've tried for years." "The P-38 has similar wings," Keller observed. "Not like this. The Lightning's wing is thicker. This is what theoretical aerodynamics looks like when you have manufacturing precision to build it." Schneider made notes. "Drag coefficient? I'll need measurements, but preliminary? Perhaps 15 to 20% lower than the Bf-109's wing at cruise. Laminar flow delays boundary layer separation. Less drag, better efficiency. Performance implications? Higher top speed at same power, longer range for same fuel. Better high-altitude performance because thin air benefits more from reduced drag than it hurts engine power. Drawbacks? Laminar wings have docile stall characteristics, but they're sensitive to surface imperfections. Dirt, ice, damage, anything disturbing smooth flow destroys the advantage. Combat conditions make maintaining that finish difficult. Yet they built thousands, Hoffman noted, which tells us about their manufacturing quality control. They moved aft to the radiator. The belly scoop was thermodynamic masterwork. Hoffman shone his flashlight into the intake. The duct expanded smoothly, without corners or transitions. At the radiator face, airflow would move perhaps 1/3 free-stream velocity, slow enough for efficient heat extraction. Behind the radiator, the duct converged, accelerating heated air through an exit nozzle carefully shaped and positioned. "Meredith effect radiator," Weber said. "Theory: if you design the duct correctly, you recover most cooling drag penalty. Heated air expands and accelerates through the exit, creating small thrust." "Does it work?" Keller asked. "Apparently. Otherwise, they wouldn't design it this way." "Compare to our systems," Weber gestured. "The Bf-109 uses underwing radiators, creating significant drag. The FW-190's radial simplifies cooling, but creates frontal area drag. This American design is more sophisticated. They've turned necessary evil into near advantage." "Maintenance requirements?" "Unknown, but notice accessibility." Weber indicated inspection panels along fuselage sides. "Designed for field maintenance, quick access, standardized fasteners." They moved forward to the engine. The Packard V1650 Merlin would have been artwork if not seized and damaged. Hoffman studied the power plant with professional admiration. A 60-degree V12 displacing 27 liters. Two-stage, two-speed supercharger mounted rear. Liquid-cooled. Fuel injected. Producing approximately 1,500 horsepower at takeoff and maintaining power to altitudes where the DB605 gasped. "Rolls-Royce design built under American license," Weber noted. "Notice the intercooled supercharger. That allows higher boost without detonation." Keller ran his hand along the mount. "Compare installation to ours. The DB605 is fine engineering, but optimized for different parameters. Lower altitude, shorter missions. This Merlin is designed for sustained high-altitude operations." "Explain." Weber pointed to the supercharger. "See the two-speed gearbox? low altitude, low gear, moderate boost. Above approximately 20,000 feet, automatic shift to high gear, increasing boost to maintain power. This gives the Merlin flat power from sea level to 30,000 feet. And the DB605? Single-stage supercharger. Power falls significantly above 20,000 feet. We use MW50 methanol water injection to compensate, but that's consumable, limiting runtime. This American engine doesn't need it. Hoffman made notes. Implications were clear. The Americans had designed an engine-airframe combination optimized specifically for high-altitude, long-range escort. Everything served that purpose. Germany had designed the Bf-109 for short-range interception and ground support, then modified repeatedly for changing requirements. The result? An aircraft doing many things adequately, but nothing optimally. "Let's examine the cockpit," Hoffman said. The bubble canopy was revelation. Keller climbed into the seat while others stood on ladders. Canopy framing was minimal, thin structural members for rollover protection. Otherwise, the pilot sat under a plexiglass dome offering nearly unobstructed visibility. I can see directly behind. No blind spots. Straight up, straight down. Only obstruction is my own seat. "Compare to the Bf-109, Hoffman prompted. The 109 has framed canopy with armor glass forward, small side panels. You can't see behind without craning, and even then, blind spots. The Gustav improved some, but nothing like this." Keller studied instruments. Everything positioned logically. Engine instruments left, flight instruments center, electrical and weapons right. Very systematic American approach. "Radios?" Keller indicated a panel below the main cluster. "VHF with multiple channel selection. Clear communication capability. Our FUG-16 is functional, but limited in range and clarity." "Oxygen system?" Keller located the regulator. "Demand type. Delivers oxygen only during inhalation, conserving supply. More efficient than our continuous flow systems." Weber studied the gun sight. "Gyroscopic computing sight. Automatically adjusts for target motion and range. Pilot just frames target and maintains range. Sight does ballistic calculations." "We have similar systems," Schneider noted. "Yes, but this appears standard equipment, not field modification or limited installation." They spent 30 minutes examining cockpit layout, control placement, ergonomics. Every detail suggested a philosophy prioritizing pilot workload reduction and combat efficiency. Finally, Hoffman stepped back. "Preliminary assessments?" They gathered in Schneider's office. Schneider opened a bottle of schnapps, real schnapps, not synthetic, and poured 4 glasses. "We are technical professionals, not propagandists. What we say here stays here. Understood?" Everyone nodded. "Major Hoffman, assessment." Hoffman sipped carefully. "The Mustang represents fully optimized design for long-range, high-altitude escort. Every system serves that purpose. Laminar wing provides efficiency. Meredith radiator minimizes cooling drag. 2-stage Merlin maintains altitude power. Fuel capacity, approximately 280 gallons internal plus external tanks, provides 1,500-mile-plus range. Compare to our fighters. Bf-109 Gustav, 400 miles combat radius. FW-190 similar. Neither sustains operations at 30,000 feet extended periods. Neither has this visibility or ergonomics." Weber set down his glass. "The Mustang's wing is approximately 15 years ahead of our production designs in aerodynamic efficiency. We understand laminar flow theory. We lack manufacturing precision to build it consistently. If we had that precision, we'd still face material shortages, fuel limitations, dispersed production. The Mustang benefits from American industrial capacity. They can afford tight tolerances, specialized tooling, quality control. We cannot." Keller spoke. "From a pilot's perspective, The Mustang is what you'd design if you asked experienced combat pilots what they needed, listened, and actually implemented suggestions. Visibility alone is worth 10 minutes combat training. Endurance means American pilots remain over Germany for hours, engaging at will, disengaging when damaged, returning when ready. Can we copy it? Schneider asked bluntly. Silence. Weber finally answered. Technically, perhaps with 2 years and unlimited resources. Practically, no. We lack alloys for the Merlin. We lack precision for the laminar wing. We lack fuel for extended operations. We lack pilots to fly them and training time to qualify those pilots. Hoffman added quietly, and even if we could copy it, the Americans produce them at rates we cannot match. The strategic situation makes this academic. Schneider refilled glasses. We will test this aircraft anyway. We will document performance, handling, capabilities, and limitations. We will compile technical reports for distribution. This is our duty. He raised his glass. To professional objectivity, gentlemen. To seeing things as they are, not as we wish. They drank. Outside, through the window, Hoffman could see the Mustang in Hangar 7, surrounded by mechanics and engineers. In fading light, the American fighter looked almost ethereal, a ghost from a different, more technologically advanced war. Part 4. Flight Test. April 27, 1944. The replacement Merlin arrived from Kaufering Salvage Depot, a complete power plant from another downed P-51. Flak damaged over Munich, but with intact engine block. 6 days to install, working from hastily translated English manuals and photographs. Hauptmann Keller watched with patient understanding that rushing aircraft maintenance was how pilots died. The installation was elegantly complex. The Merlin mounted on tubular steel bearers, distributing load across 4 attachment points. Coolant lines, oil lines, fuel lines, electrical harness, control cables. Everything connected precisely, tested, verified. April 27 morning, Chief Mechanic Oberfeldwebel Richter approached with a clipboard. Herr Hauptmann, engine installed. Ground runs complete. All systems functioning within parameters. Fuel? 50 gallons 100 octane from captured stocks. Approximately 1 hour flight testing. Keller nodded. American 100 octane was significantly better than German 87 octane standard, meaning the Merlin would run cleaner with more power. Testing with inferior fuel would give false results. I'll fly this afternoon, 2 o'clock. Richter hesitated. Herr Hauptmann, we have no technical data on handling characteristics, no pilot notes, no performance charts. I know. If something goes wrong, then I'll deal with it. That's why they pay me, Richter. Keller spent 3 hours studying available documents, translated manual, preliminary inspections, Weber's aerodynamic analysis. He memorized instrument panel layout from photographs. He reviewed emergency procedures, what he could deduce from technical drawings. At 1400, he walked to the flight line. Pre-flight inspection was thorough. Keller circled the Mustang, checking control movement, examining tires, verifying fuel quantity. The aircraft carried no ammunition, 50 caliber guns removed to save weight and reduce variables. This was testing, not combat. He climbed into the cockpit with Hoffman on the wing providing guidance. Primer pump here, 6 strokes. Mixture full rich. Throttle cracked 1 inch, magnetos both. Keller followed the checklist, hands moving over unfamiliar controls. The cockpit smelled different from German aircraft. Different oils, materials, a faint scent of American cigarettes from the previous pilot. Battery on, booster coil on. When ready, starter. Keller pressed the button. The Merlin coughed once, twice, caught with a rumbling growl building into smooth, powerful roar. The propeller blurred. The airframe vibrated with contained energy. Keller scanned instruments. Oil pressure rising green, coolant temperature climbing gradually, manifold pressure steady. The Merlin ran smoothly, without roughness characteristic of German engines with hundreds of hours. Hoffman climbed down, thumbs up. Keller released brakes and taxied toward the runway, feeling ground handling. Tail wheel steerable through rudder pedals. Brakes powerful and responsive. Forward visibility excellent, far better than the Bf-109's long nose. At the threshold, takeoff checks. Controls free, trim set, mixture rich, propeller forward, flaps up. Tower cleared him. Keller advanced the throttle. The Mustang accelerated like nothing he'd flown. Tail up almost immediately. Airspeed unwound rapidly. 40, 60, 80. At 90 miles per hour, Keller eased back and the Mustang lifted effortlessly, climbing with eager power. He raised gear and felt immediate drag reduction. Subtle, but noticeable acceleration increase. The aircraft climbed at 2,000 feet per minute at normal power. At 5,000 feet, Keller leveled and began evaluation. First, basic handling. Gentle turns, feeling control response. Ailerons light and responsive, far lighter than the Bf-109's heavy cable-operated controls. Elevator harmonized beautifully.
Rudder required moderate force, but was effective. Stall test. Power off, nose high, speed bleeding. The Mustang shuddered gently at 95 miles per hour and dropped its nose without wing drop or violence. Recovery immediate with power. Next, speed. Keller pushed to maximum continuous power and leveled at 10,000 feet. Airspeed built steadily. 250, 280, 300, 320 miles per hour indicated. The aircraft remained stable and smooth. No vibration, no buffeting, just clean, efficient speed. Engine instruments. Cylinder head temperature well within limits. Oil pressure steady. The Merlin was loafing, producing power without strain. Steep turn. 4 gravities. The Mustang carved through air like on rails. Wing loading high, but controls still responsive. He reversed. Same result. Crisp, precise, predictable. At 20,000 feet, he repeated maneuvers. The Mustang's performance barely degraded. Controls remained responsive. Engine maintained power. This was the critical difference. The Bf-109 became sluggish above 20,000. Controls stiffened. Engine gasped. You fought the aircraft as much as the enemy. The Mustang simply continued flying, as if altitude were irrelevant. After 40 minutes, Keller returned to Rechlin. On the flight line, a crowd had gathered. Mechanics, engineers, pilots, administrative officers. Everyone wanted to see the captured American fighter fly. Keller configured for landing, gear down, flaps down, and flew standard approach at 110 miles per hour. The Mustang settled with barely a tire chirp. He taxied back and shut down. Silence after the Merlin stopped was profound. Hoffman waited when Keller climbed out. Well? Keller removed his helmet, choosing words carefully. The crowd waited. It is better than the Bf-109, in every measurable parameter, except possibly initial roll rate. Faster, climbs better, better visibility, better handling at altitude, and, he gestured at fuel gauges. I used perhaps 20 gallons in 40 minutes, including climb to 20,000 feet. Endurance is extraordinary. Weber approached with notebook. Specific observations? The laminar flow wing is real. I could feel it. The aircraft slips through air with minimal drag. Stall characteristics benign. Controls well harmonized, effective at all altitudes. Visibility from bubble canopy is transformative. I could see threats from any angle. Compared to the Gustav? Someone asked. Keller turned. The speaker was Major Heinrich Baer, frontline pilot with 180 victories, at Rechlin for the demonstration. The Gustav is good, Keller said carefully, but designed for different mission parameters. Low altitude work, short-range interception. The Mustang is optimized specifically for high-altitude, long-range escort in ways we cannot match with current designs. Bear's face was unreadable. So, if I meet one over Berlin? Use altitude if you have it. Use surprise. Engage and disengage quickly. Don't let them draw you into sustained turning fights at high altitude. They have endurance to outlast you, and visibility advantage means they see you first. If I have no altitude advantage? Keller met his eyes. Then run. Dive away. Use your superior roll rate to break tracking. Don't stay engaged. The crowd was silent. Bear nodded slowly and walked away. That evening, they compiled test data. Hoffman measured fuel consumption, 0.5 gallons per minute cruise power. With 280 gallons internal plus external tanks, the Mustang could remain airborne 8 hours or more. Weber calculated approximate drag coefficient from observed performance, significantly lower than Bf 109, as predicted. Keller provided handling notes, stable, responsive, forgiving at all altitudes. Schneider assembled preliminary report. Technical evaluation, P-51B Mustang. Performance, maximum speed, 25,000 feet, approximately 440 miles per hour, estimated from flight test. Service ceiling, approximately 40,000 feet, limited test to 20,000. Combat radius, approximately 750 miles with external tanks. Endurance, 7 to 8 hours with external tanks. Climb rate, 2,000 plus feet per minute sea level. Comparative versus Bf 109 G6. Speed advantage, plus 40 miles per hour at altitude. Climb, comparable sea level, superior above 20,000 feet. Endurance, 4 to 5 hours greater. Visibility, significantly superior. High altitude handling, superior across all parameters. Tactical implications. P-51B can escort American bombers to any Reich target and return. German interceptors can no longer exploit escort coverage gaps. Engagement must occur through escort screens at all phases. American numerical and qualitative escort advantages now render bomber interception extremely costly. Technical countermeasures. None feasible within current constraints. Replication requires. Two-stage supercharged engine, unavailable. Laminar flow wing manufacturing, precision beyond capability. Extended fuel capacity, weight/volume constraints. Minimum 18 to 24 month development, unacceptable given strategic situation. Recommendation: tactical adaptation only. German interceptors should avoid prolonged escort engagement. Priority: high-speed hit-and-run on bombers, immediate disengagement upon escort intervention. Schneider signed and filed the report. Distributed tomorrow. Fighter Command, OKL Headquarters, Technical Groups. Will anyone listen? Keller asked. That's no longer our concern. We provided data. Others make strategic decisions. Part 5. The Mathematics of Defeat. May 2nd, 1944. Final Assessment Conference. 6 men in the conference room. Oberst Schneider, Major Hoffman, Hauptmann Keller, Diplom-Ingenieur Weber, Major Baer, and General Major Adolf Galland, General of the Fighter Arm, flown from Berlin specifically for this briefing. Galland was legend. 104 victories. Youngest Luftwaffe general. A pilot who understood tactical reality better than most staff officers. He listened, smoking a cigar, while Hoffman presented compiled data. The P-51B represents fully integrated weapon system optimized for long-range, high-altitude escort, Hoffman concluded. Testing confirms performance advantages in speed, range, altitude capability, and pilot ergonomics. Direct comparison demonstrates superiority across all relevant combat parameters above 15,000 feet. Gallen studied performance charts. Below 15,000? The Bf-109 retains advantages in initial acceleration and roll rate, but American fighters rarely engage below 20,000 feet. They hold altitude and dictate engagement terms. Can we develop countermeasures? Weber answered. Technical countermeasures require fundamental fighter redesign incorporating two-stage supercharging, extended fuel capacity, aerodynamic refinement. Estimated development, 24 months minimum. Production implementation, additional 12 months. This assumes no material shortages, no bombing disruption, no competing priorities. In other words, Gallen said quietly, impossible. Not impossible, Herr General. Impractical given circumstances. Gallen turned to Bear. You flew against this aircraft. Tactical assessment. Bear chose words carefully. Our pilots can kill the Mustang with surprise, superior altitude, immediate disengagement. But this requires perfect conditions rarely achieved. The Mustang's visibility advantage makes surprise difficult. Their numerical superiority means they maintain altitude reserves. Their endurance means they pursue damaged aircraft. Survival rates? Direct engagement at equal altitude? Very poor. Perhaps 1 in 4 pilots survives against equally skilled opponents. Against more experienced Americans? Worse. Silence. Gallen stood and walked to the window, looking at the captured fighter. He smoked methodically, calculating odds that wouldn't balance. Gentlemen, he finally said, I need honest assessment, not what you think I want to hear. What is the strategic implication? Hoffman spoke first. The Americans have solved the escort problem. Bombers reach any Germany target with continuous fighter protection. Our interception strategy, engaging during unescorted phases, no longer applies. Weber added, they produce these at rates we cannot match. Intelligence suggests North American Aviation's California plant builds 40 to 50 Mustangs daily. We build perhaps 15 Bf-109s and FW-190s combined per day, and that decreases as factories are bombed. Production ratio 3-to-1 in their favor, Schneider noted, and their aircraft are qualitatively superior. If we throw experienced pilots against these escorts in mass formations, Galland asked. We lose the experienced pilots, Bear said flatly. I've seen it, Herr General. Good men, survivors from Russia and France, killed their first week against Americans, not from lacking skill, because mathematics don't favor them. What do you recommend? Silence. Hoffman finally spoke. We are no longer fighting pilots, Herr General. We are fighting an industrial system. The Americans have resources to design, test, refine, and mass-produce an optimized fighter. They have fuel to fly it, pilots to man it, infrastructure to support it. We do not. Galland crushed his cigar with deliberate precision. This assessment stays in this room. Officially, we continue emphasizing pilot skill, tactical innovation, our fighters' capabilities. But among ourselves, we must be honest. He looked at each man. The air war over Germany is lost. Not from any failure of courage or skill, but because we ask our pilots to perform miracles with inadequate tools. Every mission now is attrition. Every victory costs irreplaceable pilots. The enemy replaces losses faster than we inflict them. What do we tell the fighter groups? Keller asked. Fight intelligently, avoid prolonged engagements, hit and run, survive. Because dead heroes cannot defend the Reich. Galland walked to the door, paused. The Mustang. What will you do with it? Retain it for continued evaluation and identification training, Schneider said. Good. Let them see what they're facing. Let them understand reality. Gallon left without saluting, a protocol breach no one remarked upon. That evening, Hoffman sat alone in the hangar with the Mustang. The aircraft was being prepared for storage, fluids drained, systems deactivated, components preserved. It would remain at Reckland for the war's duration, a trophy and a warning. He ran his hand along the wing's leading edge one final time, feeling perfect smoothness of the laminar flow surface. Everything about this aircraft represented a philosophy he respected: careful design, rigorous testing, systematic optimization. The engineers who created it had been given time and resources to solve problems correctly. The result was elegant, efficient, and deadly. Germany had started the war with superior aircraft and pilots. But wars weren't won by starting well. They were won by sustaining capability, production, training, innovation, resources. The Mustang was proof America had achieved that sustainability. Germany had not. Hoffman turned off the hangar lights and walked into spring darkness. Above, stars appeared, cold and indifferent. Somewhere over Germany, bomber streams flew tonight, escorted by fighters like the one sleeping behind him. The mathematics were complete. The conclusion was inevitable. The war would continue, months, perhaps a year or more. But the essential question had been answered. Not on battlefields, not in tactical victories. In an engineering analysis, in performance charts, in the simple, undeniable reality of one aircraft compared to another. Hoffman walked back to his quarters, footsteps echoing on empty concrete. Tomorrow the bomber streams would return, and German fighters would rise to meet them, flying aircraft obsolete before they left the ground. Not from any failure, simply from arithmetic. The Mustang remained in its hangar, a ghost from a different war, fought by nations with different capabilities. And in the morning, the sky would fill again with contrails and fire, and young men would die in machines that could no longer win. Because that was what the numbers said, and numbers, unlike men, could not be argued with.